and welcome to today's class. For today, we're looking at the concept of density, relative density, Archimedes principle, and Upthrust. And we're using all of these concepts to solve Jamb past questions. But before then, let's consider these concepts and understand what they mean. Alright, first things first, let's look at density. Now, density by definition is simply the mass acting per unit volume of a substance. Alright, density is represented by the Greek symbol rho. That's this, rho. And mathematically, density is equal to mass over volume. So mathematically, density, that's rho, is equal to mass all over volume. Mass is measured in kilogram all over volume is in meter cube. Therefore, my SI unit for density is kilogram per meter cube. That's kilogram meter to the power -3. So this is for density. It is important to note that the density of any particle, of any matter is constant. Alright, it doesn't change. For instance, the density of water is 1000 kilogram per meter cube or 1 gram per cm cube. Also, the density of mercury is 13,600 kilogram per meter cube or 13.6 gram per cm cube. Alright, so always note that density of any substance is a constant, it doesn't change. Let's look at the next concept called relative density. Relative density is also called specific gravity. By definition, it is the ratio of the density of an object to the density of water. Alright, so relative density, RD, also called specific gravity, is equal to density of objects of anything there all over density of water. Alright, so this is a formula for relative density. Now, aside this, there is another formula for calculating relative density. That is a formula in terms of weight, in which we say that relative density, that's RG, can also be got by the weight of a body in air all over the weight of that body in water. So this is another formula of calculating the relative density of an object. Alright, weight in air all over weight in water, or you can say density of the object all over density of water. So anyone there can go. Alright, so still on this, let's look at a very important principle. Let's look at a very important principle that we need for a calculation called Archimedes principle. Now, Archimedes principle states that when a body is partially or totally immersed in a fluid, that it experiences an upthrust which is equal to the weight of the fluid displaced. Alright? Archimedes principle states that when a body is partially or totally immersed in a fluid, that it experiences an upthrust which is equal to the weight of the fluid displaced. That is Archimedes principle. There's a key concept in Archimedes principle called upthrust. So we're saying for Archimedes principle that upthrust is equal to weight of fluid displaced. This idea is from Archimedes principle. Alright, let's look at something. We just said, let's derive an expression for upthrust. Alright, let's find an expression for upthrust. By the way, what's upthrust? By definition, upthrust is simply the force exerted by a liquid on an object that is being placed into it. Alright, so when an object of weight W is being placed into a liquid there, the liquid itself will exert a weight or a force on that object. That's called upthrust. A simple diagram of that will be this. So I'm having this as a bucket and placing a particular weight W into this, alright, so that the weight is coming downward. So I have this one here. So this is fluid, and I'm placing a particular weight here. Of course, this weight has to act downward. For there to be equilibrium in this, my downward force has to be opposed by an upward force. The upward force that will be opposing this weight is what is called upthrust. Alright? So that's upthrust. Upthrust is the force, or is the upward force exerted on any solid or any material placed in a liquid. That's it. Alright. So having said that, let's look at the formula for upthrust. Well, let's consider upthrust. Alright. So I just defined upthrust as the force that a liquid, or the upward force that a liquid exerts on an object that is being placed in it. That's upthrust. Upthrust, U, mathematically is equal to the difference between the weight of an object in air minus the weight of that object in a liquid. Alright? So the upthrust that the liquid provides, or the upthrust that the liquid exerts on any solid or any body is equal to the weight of that body, air, minus the weight of that body in the liquid. Of course, upthrust is also known as loss in weight. Alright? Upthrust causes a loss in weight. Alright? Yes, causes a loss in weight of material. And this is why materials tend to be lighter when they're inside any liquid than when they're out. And this explains the concept. If you've ever drawn water from a well, you observe that while the bucket, in quote, is still inside the well, it is very easy to draw it out. But immediately the bucket leaves the well, it becomes very heavy. And this is because when a bucket is inside the well there, it will lose some of its weight due to the upthrust of the liquid on that bucket. So immediately the bucket leaves the well there, what happens is that there is no more upthrust to balance the weight here, or there's no longer a loss in weight. So hence the full weight of that bucket will be felt by the person drawing the water from the well. So that is a simple scientific explanation for that concept. So this is one formula for upthrust. Now aside this, we know that weight or upthrust is equal to mass times gravity. Alright? So I'm saying that weight is equal to upthrust. Alright? Weight of fluid displaced is equal to upthrust. So you can say that upthrust equal to weight is equal to mass times gravity. But if you look at this formula here, we said that density rho is equal to mass all over volume. We have this. If I cross multiply from here, this is all over 1, becomes mass times 1, that's mass, is equal to density times volume, that's density volume, rho v. If I put this one here into this equation, it means that the upthrust U is equal to mass. We just said mass is equal to rho v, so it becomes mass, that's rho v, that's mass, times gravity, that's g here. So if I multiply this, upthrust is equal to rho vg. So having rho vg. So this is a formula for calculating upthrust. That the upthrust exerted by a body, or the upthrust exerted by a liquid on a body, is equal to the product of the density of that liquid and the volume of the solid and acceleration due to gravity. So it's important to note that this density is density of the liquid, not the solid. Alright? this volume is volume of the solid, not the liquid. So if I'm having this here, for the Upthrust here is equal to density of the liquid, not of the solid. And the volume used here is volume of the solid being imputed, not the liquid. Alright, so it's important we know this please. So Upthrust is equal to density of liquid times volume of solid times acceleration to gravity. Alright, so let's use all these concepts to solve problems involving density and relative density. But before we go, please note that relative density is measured using an instrument known as the hygrometer. So the instrument for measuring density is called hydrometer. So write it here. H-Y-D-R-O-M-E-T-A-R. Alright, so hydrometer. Hygrometer is an instrument for measuring the density of for measuring the relative density of a fluid or an object. Alright, so take our first example. The first example says a body weighs 0.30 Newton in air, 0.25 Newton when fully immersed in water, and 0.27 Newton when fully immersed in a fluid. Calculate A, its loss in weight in water, B, its relative density, C, the relative density of the liquid. Alright, solution please. So we'll start off by listing out our given parameters here. So we are given number 1, the weight of the body. So let's say the weight of the body in air. So weight in air as being equal to 0.30 Newton. Number 2, they said 0.25 when fully immersed in water. So weight in water, so I'll use W water as being equal to 0.25 Newton. Also, they said number 3, when immersed in a fluid or in a liquid. So weight in liquid, we don't know the liquid, so just write liquid as being equal to 0.27 Newton. So we have this. The I part says calculate the loss in weight in water. So I, loss in weight, the loss in weight in water, the loss in weight in water, that's the Upthrust. We said loss in weight is simply weight in air minus weight in water. So that becomes weight in air minus weight in water. And that will be equal to weight in air is 0.30 minus weight in water 0.25. So hence the weight in air, the loss in weight is equal to, this will give us 0.05. That's 0.05 Newton. So that's an Upthrust or loss in weight. Number 2, or the B part. So this is for A. Let's call this A. Let's look at the B part. The B part says its relative density. Now we already said relative density is equal to weight in air minus equal weight in water. Now we said weight in water there. The weight in water there is simply using the concept of Archimedes principle, that when a body is totally or partially immersed in a fluid, it experiences an upthrust equal to the weight of fluid displaced. So the weight you have here is not just the weight of the body in water, but the weight of fluid displaced, which of course is also equal to the upthrust. So you can say it's also equal to the upthrust. That's still fine. So this will now be equal to weight in air is 0.30 all over the upthrust is 0.05. If I divide this, it means that relative density is equal to, get my calculator. So I have 0.3 divided by 0.05, that's about 6. So relative density is 6. Please note that relative density has no SI unit, so it's just 6. Finally, the C part. C part said, it said the relative density of the liquid. Relative density of the liquid. Relative density of the liquid is equal to Upthrust in liquid all over the Upthrust in water. So that will be equal to weight in air minus weight in liquid all over weight in air minus weight in water, and that's equal to weight in air 0.3, so 0.3 minus weight in liquid 0.27 all over weight in air 0.3 minus weight in water 0.25. Alright, if I work this out, this is equal to 0.3 minus 0.27 should give you 0.03 divided by 0.30 minus 0.25 gives you 0.05. If I divide these two, I'll have that 0.03 divided by 0.05, that's about 0.6. That's 0.6. That's your answer. Alright, so this is how we calculate this. Remember that we said that relative density has no SI unit. So the answer is 0.6. So 0.6 is the relative density of the liquid. Alright, so this is how we solve this question. Okay, so let's look at yet another example. This question says a metal block of density 9,000 kg per meter cube weighs 60 Newton in air. Full stop. Find its weight when it is immersed in paraffin wax of density 800 kg per meter cube. Take G to be equal to 10 meters per second squared. Alright, so let's get this done. So solution. Our task, as usual, would be, first of all, list out given parameters. So what are we given there? Now it says a metal block of density. So the first thing I'm given there is density of block. So I'm calling this rho block, density of block. That's about 9,000 in kilogram per meter cube. That's the first thing there. Next it says weighs 60 Newton in air. Number 2, weight of block in air. So let's say weight in air is equal to 60 Newton. Now it says find its weight when it is immersed in paraffin wax of density. So the third thing there is the density of paraffin wax. So let me just say density of wax is equal to 800 in kilogram per meter cube. Finally, they said you should take gravity G as 10 meters per second squared. Alright, so in this question, we are asked to find the weight in paraffin wax. Now, let me explain this question before we start. Now, try to picture this. So picture a jar like this that contains paraffin wax. So PW, paraffin wax. And then I put a metal block inside here. Of course, we said when it's solid, like a block is being immersed in the fluid, that it will lose weight. And this loss of weight is because there's an Upthrust acting upwards. Alright? While the weight of the block is acting downward, W, we said the Upthrust U will be acting upwards. If I'm to balance this is coming downward, becomes W. So from from Archimedes principle, we said Upthrust is equal to weight. For there to be equilibrium here, if I move Upthrust over here, upthrust becomes minus U equal to 0. Now, if I want to get the weight of the block in the paraffin wax, what I need to do is this. Subtract the upthrust by the paraffin wax on the block from the weight of the block in air. So with that said, the weight of the block in air is 60 Newton. So we have this value as the weight of the block in air as 60 Newton. Our task would be to find the upthrust of the block in paraffin wax. So how do we get upthrust? Remember that we said upthrust U is equal to rho Vg, density of the paraffin wax, which we have here. Next up, volume of the block, which is block in this case. So I have to get volume of the block first. How do I get volume of the block? So let's get volume of the block. Alright, so to get volume of the block, we can use what's it called? Density. He said density is equal to mass over volume. This is over 1. Or you can say these two simply exchange. So V comes here. V is equal to mass over density. This is correct. So my task would be get the mass of the block and then get the density, which we already have, of the block. So let's get the mass of the block. How do we get mass of the block? In this question here, the mass of the block is not given. But then, the weight of the block in air is given. And we know fully well that weight is equal to mass times gravity. So I can get the mass of the block by dividing here by gravity, dividing here by gravity. This cancels it. So let's get mass of block. So first of all, mass of block M is equal to weight over gravity. That's W all over G. And that's equal to, the weight is 60 all over gravity 10. That means the mass of the block is equal to 6 kilograms. I've gotten this. So with this now, I can now get volume of block. So volume of block V is equal to mass of block all over density of block. So mass of block all over density of block. Alright, so the volume of block V of block is equal to mass of the block is 6 kilograms all over density of the block is 9,000. So if I divide the 6 all over 9,000, what do we get? 6 over 9,000. That's about 6.67 times 10 to the power minus 4, of course, volume in meter cube. So just to confirm that from here, 1, 2, 3, 4. Alright, so 6.67 times 10 to the power 4 minus 4 is the volume of the block. Alright, after saying this now, let's look at the upthrust. So we said upthrust U is equal to density of liquid, which in this case is wax, paraffin wax, wax times volume of block times gravity. So upthrust is equal to density of paraffin wax 800 times volume of block 6.67 times 10 to the power minus 4 times gravity 10. So the upthrust is equal to 800 times 6.67 times 10 to the power minus 4 times 10. That gives you 5.34 Newton to 2 decimal places. So therefore, we can now get that the weight, we are asked to find, the question says we should find the weight when it is immersed in paraffin wax. So the weight in paraffin wax will be equal to the weight in air minus upthrust. That's equal to weight in air is 60 minus the upthrust 5.34. The upthrust provided by the paraffin wax on the block. So 60 minus 5.34, that's about 54.66. I'm looking for what there? Weight. So that should be Newton. Alright. So the answer becomes 54.66 Newton. So this is the weight of the object of the block in paraffin wax. So this is how we solve this question. Alright. So we'll take some Jamb questions and revise them together. Now the first question here says, a solid weighs 10.5 Newton in air and weighs 5.5 Newton when immersed in a liquid of density 900 kilogram per meter cube. Calculate the volume of the solid. Alright, so solution. Given number 1, they said the solid weighs 10.5 Newton in air. So first of all, weight in air, that's equal to 10.5 Newton. Next up, number 2, what else have I given? They said, and weighs 5.5 when immersed in a liquid. So weight in the liquid, W liquid, is equal to 5.5 Newton. They said, in a liquid of density, so rho liquid, density of the liquid is equal to 900 kilogram per meter cube. So we have this. We have to find the volume of the solid. This question is easy. What we know is this. We know that upthrust is equal to density of the liquid times volume of the solid times gravity. And of course, gravity is a constant. In this question, we're given any value for gravity. No, we were not given any value for gravity. So we'll take gravity as 10 here. So my first task will be to get upthrust first. And we know that upthrust, so first things first, upthrust, that's U, we said is equal to weight in air minus weight in liquid. And that's equal to weight in air 10.5 minus weight in liquid 5.5. If I subtract this, I'm having that the upthrust 10.5 minus 5.5 is 5. So upthrust U is equal to 5 Newton. So I have this. But we also know that upthrust U is equal to, of course, upthrust is equal to density of the liquid times volume of solid. What term was this here? Let me get the term here. The term says volume of the solid. So fine. So volume of solid times gravity. So that means that 5 is equal to density of liquid, that is 900, sits here, times volume of solid times 10. So to get the volume of the solid, divide here by 900 times 10, divide here by 900 times 10. So this will cancel this will cancel this. Better still, you can still multiply 900 times 10 and get 9,000 first. You see have the same answer. So from here, it means that the volume of the solid is equal to 5 all over 900 times 10 is 9,000. So 5 over 9,000, that's about 5.56 times 10 to power 1, 2, 3, 4 minus 4. Volume is in meter cube. So my answer is 5.56 times 10 to the power minus 4. And that's option D. 5.56 times 10 to the power 4. So that's option D. Alright, so that's how you solve this question. So let's do another question here. This question says, a cube of side 0.1 meter hangs freely from a string
What is the upthrust of the cube when totally immersed in water? Density of water is 1000 kilogram per meter cube, not square, meter cube, and that should be G equal to 10 meter per second square. Right, so let's get upthrust of the cube. Now we know that upthrust of the cube, upthrust U, is equal to density of the liquid, which the liquid in this case is water, and that's 1000 times volume of the cube times gravity, which is 10. So my this is already given 1000. This is already given 10. Let's find volume of the cube. Now we know that volume solution. We know that volume V is equal to length times breadth times height. But in this case, I'm giving just one of the sides as 0.1 meter. But don't forget, this is a cube, and for a cube, all the sides are equal. That means the length is equal to the breadth is equal to the height. Hence, you can see that volume of cube is equal to the length, that's 0.1, times the breadth, another 0.1, times the height, another 0.1, is a cube. All the sides are equal. So if I multiply this, I'm having 0.1 times 0.1 times 0.1. The volume of the cube is equal to 0.001 meter cube. Alright, so that's the volume of the cube. So from here, therefore, let's get the upthrust. Let's get the upthrust. So the upthrust will be equal to density of the liquid, which in this case is water, H2O, times volume of cube times gravity. So I'll have that upthrust U is equal to, this is 1000 times volume of the cube is 0.001 times gravity is 10. So I'm having this. So if this multiplies this, you will have 1 times 10 is 10. So the upthrust is equal to 10 Newton. And that is option D, 10 Newton. So that's how you solve this question. So this question says, an object weighs 30 Newton in air and 21 Newton in water. The weight of the object when completely immersed in a liquid of relative density 1.4 is dash. Alright, solution. So first things first, list out given parameters. List out given parameters. Number one, we said an object weighs 30 Newton in air. So weight in air is equal to 30 Newton. Next up, we said and 21 Newton in water. So weight in water is equal to 21 Newton. They said the weight of the object when completely immersed in a liquid of relative density. Number 3, I'm giving relative density of liquid being equal to 1.4. Alright. They asked to find the weight of the object when completely immersed in this liquid. So how do we get this? The weight of the object will be equal to, of course, we said, let's call this usual glass jar containing the liquid, and the object is being immersed. The weight of the object, as we said, will act downward, and the liquid itself will exert an upthrust on the object such that the weight now becomes weight minus upthrust. So it becomes weight in air, which we already have here, minus the upthrust in the liquid. So I need to get the upthrust in the liquid. I know that the upthrust in the liquid is equal to density of the liquid times volume. Volume of the object in air times gravity. Let's see our question. Do we have density of liquid? No, we are given relative density. From relative density here, we can get the density. From relative density here, we can get density of the liquid. So we can get this one here. G is a constant. What about the volume of the object? volume of objects, we can get, okay, what do we know? We know that density of objects is equal to mass of objects all over volume of objects. We can get mass of the object by saying weight is equal to mass times gravity. Divided by gravity, we can get the mass of the object. But then, if we get mass of object, we were not given the density of the object. So hence, this one cannot work here. So in that case, then what do? We would instead use the upthrust of, now, we can also see that upthrust, the upthrust of water, right? The upthrust of water on the object will be equal to density of water times volume of object times gravity. So in this case, we have two upthrusts. The first upthrust is the upthrust of the liquid on the object, and the second upthrust is perhaps the upthrust of water on the object. So in this case, let me use the grammar. Just say object or solid. They said an object. So yes, object. So first of all, let's get upthrust in water. So we know that the upthrust in water will be equal to weight in air minus weight in water. Let's get this value. That's equal to weight in air is 30 minus weight in water is 21. So the upthrust in water, so I'm writing it full now, upthrust in water is equal to 9, of course, in Newton. But I can also know this, but I know that upthrust in water is equal to density of water times volume of objects times gravity. So from here now, I can get the volume of the object. Alright, so the upthrust in water is 9. 9 equals density of water is 1000 times volume of the object times gravity is 10. Alright, so 9 is equal to 1000 times 10 becomes 10,000 times volume of object. To get the volume of object, I will divide there by 10,000 divided by 10,000. So this will cancel this. So the volume of the object is equal to 9 all over 10,000. That's 9 times 10 to the power. Let's get this 9 over 10,000. That's 9 times 10 to the power minus 4 meter cube. Alright, so I've gotten this. 9 times 10 to the power minus 4 meter cube. We have relative density of the liquid. Let's get density of the liquid. Density of liquid. Density of liquid. Now we said relative density is equal to density of liquid all over density of water. If I do over 1 here, it means that density of liquid is equal to relative density of liquid times density of water. So hence, density of liquid is equal to, that's rho liquid is equal to relative density of liquid, that's RD liquid, relative density of liquid times density of water, so density of water. So this becomes the formula. Let's get density of liquid. Alright, so density of liquid is equal to this value. Let me guess again, clean it. Let me get so this test again. So this density there was 1.4. Becomes 1.4 times 1000. This is the value of density of water. So 1.4 times 1000, that's equal to 1400 density kilogram per meter cube. So this is density of the liquid. So from here now we can now get upthrust. Let's now get the upthrust. Let's get upthrust in liquid. So upthrust in liquid, U is of liquid, fine. U liquid is equal to density of liquid times volume of objects times gravity. Alright, so this is equal to density of liquid is 1400, that's this, times volume of objects is this, 9 times 10 to the power minus 4 times gravity, that's 10. Alright, so I multiply this gives you 1400 times 9 times 10 to the power minus 4 times 10. That's about 12.6 in Newton. This is the upthrust. So this becomes the upthrust or the loss in weight of the object in the liquid. So if the object will lose this amount of weight when it is placed inside the liquid, what then is its weight? So it becomes the weight in air minus this one here. Alright, so let's get the weight in the liquid. So therefore, weight in liquid becomes weight in air minus the upthrust in liquid, and that's equal to the weight in air. Let me get the value again. The weight in air then was 30 newtons. It becomes 30 minus upthrust in liquid 12.6. So subtract 30 minus 12.6. So I'm having 30 minus 12.6. That's about 17.4 newton. Alright, so this is the weight in air, 30. If I place the object inside the liquid, it will lose this amount, it will lose 12.6 newton. So what I'm left with is 17.4 newton. So this becomes the answer. So this is how you solve this question. So the question says, an object weighs 22 kilogram in water and 30 kilogram in air. What is the upthrust exerted by the liquid on the object? Solution. So given, number one, it said it weighs 22 kilogram in water. So number one, I have weight in water, which is equal to 22 kilogram. And 30 kilograms in air. Weight in air, that's equal to 30 kilograms. What is the upthrust exerted by the liquid on the object? My first task is to convert. These are not actual weights. They are actually masses. So the first task is to convert these masses to weight, and I'll do that by multiplying by 10. Multiply this by 10, I'll have 220. Multiply this by 10, I'll have 300 in Newton. So I now have these values as my actual weight. I'm asked to find the upthrust. Find the upthrust exerted by the liquid. So it said upthrust U is equal to weight in air minus weight in water. Alright, so that will be equal to weight in air is 300 minus weight in water is 220 using the Newton values. 300 minus 220 gives you 80 Newton. So therefore, the upthrust is 80 Newton. So this is how you solve this question. Alright, let's try this question here. So this question says, a balloon whose volume is 300 meter cube is filled with hydrogen. If the density of air is 1.3 kilogram per meter cube, find the upthrust on the balloon.
So solution. So this is quite straightforward. I'm giving the volume of balloon to be equal to 300 meter cube. Density of air has been equal to 1.3 kilogram per meter cube. G has been equal to 10 meter per second squared. Find upthrust. You know that upthrust is equal to rho Vg. Now observe that in this case now, they said the volume is filled with hydrogen gas. So in terms of gas, they gave you density of air. That's what you should note. When you are working with liquid, paraffin wax, and liquid, they do give you density of water. Alright? So here's the concept. Relative density is equal to density. We said relative density of a liquid is equal to density of that liquid all over density of water. Now this is for liquids. In the broader concept, relative density is equal to density of liquid all over density of what? A standard liquid. For liquid, the standard liquid there is water. While if you're dealing with gases, for gases, the standard liquid there is what? Air. That's why in this case, when you're giving hydrogen, they give you density of air. And that's the idea there. Alright, so let's include values here. So this is now equal to density of air, which is 1.3 times volume of the balloon, 300 times gravity, that's 10. So if I multiply that's the upthrust is equal to, I'm having 1.3, so that's 1.3 times 300 times 10, that's about 3,900, about 3,900 Newton. Alright, so that's the answer. That here is option C, 3,900 Newton. So that's how you solve this particular question. Alright, so this question says, a hygrometer is an instrument used in measuring, the answer is what? Relative density of a liquid, and that's option B. Okay, so we look at one final concept that has to do with fraction or ratio of volume, and then we'll solve a final example, and that's all for today's class. Alright, so let's look at one last concept. We'll solve a final example, and that'll be all. Now this one says the relative density of ice is 0.92. What fraction of the volume of a piece of ice will be submerged when floating in A says water, B says a liquid of relative density 1.11. Take the density of water as 1 gram per cm cube. Alright, let's get this done this. So solution, for questions of this form, the simple idea is this: multiply the volume of the object by the relative density of the object and equate it to the volume of any of the liquid times the relative density of that liquid. Alright, I will solve this and see how it's done. So first things first, what are we giving here? Number one, I'm giving relative density of ice as being equal to what there? 0.92. Okay. So also in the B part, okay, so before we come to B, let's look at the A part there. The A part says water. Okay, so let's get this done. For water, we said to solve this one here, when it comes to finding the fraction of volume that will be submerged, the simple idea is this: take the volume of ice, multiplied by relative density of ice to be equal to the volume of water multiplied by relative density of water. This is a simple concept. Alright. So from here, I'm having that volume of ice times, this should be 0.92 is equal to volume of water times relative density of water. On the question there is 1 gram per cm cube. So I'm having 1. Okay. So this gives you 0.92 times volume. Okay. So 0.92 times volume of ice is equal to, this times 1 is itself volume of water. To get the volume of the question says, to get the fraction of the volume of the piece of ice that will be submerged in water, it will be equal to, we'll look for a way to get the ratio of volume of water all over volume of ice and see what we have as our answer. So from here, if to get that now, we'll have to divide both sides by volume of ice. So it becomes 0.92 multiplying the volume of ice all over, okay, equal to volume of water. So divide here by volume of ice, divide here by volume of ice. So this will cancel this. So hence I'll have that volume of water all over volume of ice is equal to 0.92. This is also equal to, of course, in terms of percentage, this is 92%, of course. Alright, so this is the fraction of the volume. This is the fraction of the volume of the piece of ice when it is submerged in water. So always remember that the idea is to get the ratio of the volume of water to the volume of ice. If they say, like in the big part, the paper says, when floating in a liquid. So my task would be, look for a way to get volume of the liquid all over volume of ice, that's all. So for the big part, the same concept here. So it becomes volume of ice times relative density of ice is equal to volume, this time in terms of the liquid, so volume of the liquid times relative density of the liquid. Liquid. Alright, so from here I have that the volume of ice times this value is 0.92, so 0.92 is equal to volume of liquid, okay, so V liquid times relative density of liquid, which in the question here is 1.11, so 1.11. Don't forget, our task will be, look for a way to express this, for us to get a fraction of volume, look for a way to express this as volume of liquid all over volume of ice. So how do we do that? So that's now equal to 0.92 volume of ice being equal to 1.11 volume of liquid. Alright, so it's as simple as divide here by volume of ice, divide here by volume of ice. So this cancels this. I have 0.92 is equal to 1.11. Shift these two aside, becomes volume of liquid all over volume of ice. To make it stand alone, I'll divide all of this by 1.11, divide all of this by 1.11. So this will now cancel this. This is mathematically correct. So it means that volume of liquid all over volume of ice is equal to 0.92 times, or divided this, divided by 1.11. That's about 0.83, which is equal to 83%. That's in terms of percentage. So this is how
we solve this question. So if you're asked to find the fraction of the volume of the piece of ice or the solid, right, that will submerge, is always equal to the volume of the liquid in which the solid is submerged all over the volume of the solid itself. So that's the concept. And you get that by multiplying the volume of the solid times relative density of the solid being equal to volume of the liquid times relative density of the liquid. We'll take a final Jamb question and we'll end the class. Alright, so let's get this done. Last question here says, a piece of cork floats in a liquid. What fraction of its volume will be immersed in the liquid? Density of the cork equal to 0.25 times 10 to the power 3 kilogram per meter cube. Density of the liquid equal to 1.25 times 10 to the power 3 kilogram per meter cube. Alright, so solution. So we said our task would be to simply get volume of the liquid all over volume of the solid, which in this case is the cork. That's this. So I look for you to get this expression, and we said we get this by multiplying the volume by relative density. Alright. It's not always by relative density, sometimes too, it's still by density. Alright. Because the idea is that if I have volume times relative density being equal to volume times relative density, and I have that volume times density is equal to volume times density. So far as these two are the same thing, I'll have the same answer. Why? Because relative density is equal to, or density itself is equal to relative density times 1000. Of course, here times 1000. And from the idea of mathematics, this 1000 can cancel the 1000. So the idea is this: you can multiply the volume by relative density if that's what you're given, or you can still use density if that's what you're given. Of course, if you need to times 1000, they will cancel out. So you don't really have to bother about the conversion. So whether it's relative density or it's density, no problem, they'll give you exactly the same answer. In this question, I'm given density. So I'll have to identify the solid here. The solid here is the cork. So it becomes volume of the cork times density of the cork. Okay, which also I'm given there. Yeah, is equal to volume of the liquid. In this case, the liquid there is what? It wasn't mentioned. It said in the liquid. So volume of liquid times density of liquid. Alright, let's get this done. So from here, the volume of the cork times density of the cork here is about 0.25 times 10 to the power 3. So I have this is equal to volume of the liquid times density of the liquid, as given in the equation here, is 1.25 times 10 to the power 3. Alright, so let's get an expression for volume of liquid all over volume of the solid, which is cork here. To do that, I'll have to divide here by volume of cork, divide here by volume of cork, such that this can cancel this. Alright, so I have 0.25 times 10 to the power 3 as being equal to volume of liquid all over volume of cork times this one here, 1.25 times 10 to the power 3. To get this one here, I will divide both sides by this value. So hence, I will have that the volume of liquid all over the volume of cork is equal to this one here, 0.25 times 10 to the power 3 all over this one here,
1.25 times 10 to the power 3. So my answer
is equal to, so 0.25 times 10 to the power 3 all over 1.25 times 10 to the power 3.
That's equal to 0.2, which in fraction is simply 20%.
Simply 20%. So the answer there is 0.2. And which option is that? That is option B, 0.2. Alright, so the answer there is option B. Alright, so this is how you solve this question. So I'll leave you with an assignment. You try out this question and then leave your answer in the comment section. Alright, I'll go through the comment section and I'll tell you if you're wrong or if you're correct. So you try this question. Alright, the question says, if a plastic sphere floats in water in bracket density 1000 kilogram per meter cube with 0.5 of its volume submerged and floats in oil with 0.4 of its volume submerged, the density of the oil is A, 800 kilogram per meter cube, B, 1200 kilogram per meter cube, C, 1250 kilogram per meter cube, D, 2000 kilogram per meter cube. A solid weighs 45 Newton and 15 Newton respectively in air and water. Determine the relative density of the solid. Alright, so drop your answers in the comment section and I'll give you a reply as fast as I can. Alright then, so see you in our next class.